Okay, this video is going to cover one-step equations, both writing them from a word sentence as well as solving them, and then also identifying independent variables and dependent variables. So let's go ahead and get started. The first thing that we are going to start with is writing word sentences as equations. So I'm going to give you a word sentence, and then you need to take that word sentence and translate it into a math problem. So our first word sentence says a number x decreased by 3 is 5. So the first thing we want to do is identify the word that we could replace with an equal sign. So here that's going to be an is. So I circle that, put an equal sign above it. And then we want to find our word or phrase that tells us what operation we're using. So here it's decreased by, and we know that's going to be subtraction. So then we need to make sure we put these variables and constants in the right order. So we know a number x is decreased by 3. So we're taking our value x, decreasing it by 3 by subtracting 3 from it, and that is equal to 5. So here we're not solving, we're just taking the word sentence and rewriting it into an equation. Our second problem says a number a divided by 7 equals 14. So again, I'm going to circle that equals and put an equal sign above it so I can replace that word with an equal sign. And then to the left of that, I have a number a, so that is our variable, divided by, and that's division, 7. So there's a couple ways we can write this. We could write a with our division sign, 7 equals 14. And while that is correct, the most common way you're going to see this is a over 7. So in fraction form, because remember that fraction bar means division. And we're going to set that equal to 14. Okay, let's try a third one. 13 less than a number r is 18. So again, I'm going to circle my is, an equal sign. And then I see this phrase less than, I know that's subtraction. But with that less than phrase, that's a little bit tricky for subtraction. So we want 13 less than whatever r is. So we're going to take our value of r and we want 13 less than that. So we're going to take r and subtract 13 from there and set that equal to 18. Again, no solving necessary. We don't need to solve for the variable. We just want to translate our word sentence into an equation. And then our fourth one here says 26 is the product of a number y and 2. So I'm going to identify my word that I can replace with equals. So 26 is the product, so we know that's multiplication, of a number y and 2. So I'm going to put 26 equal, and then I want to write the product of y and 2. So here, again, there's a few ways we can write this, but the most common way you're going to see when you have a variable and a constant that are being multiplied together is that constant's going to become the coefficient. And so it's going to go attached to the variable but go in front of that variable. Again, one of the ways you could also see this written is 26 equals 2 times y or y times 2. But here, this is going to be the most common way. So we want to try and get used to those most common ways and realize that that 2 can be placed right next to our variable without any sort of multiplication symbol. Our next problem says write an equation that can be used to find the value of x. So it doesn't say find the value of x, it just says write an equation that we could use to find it if we needed to. So here, this is a rectangle. So if we think of the area formula of a rectangle, that's a equals length times width. We do know that the area is 84 square units, so I'm going to plug in for that a, the 84 that we're given. And then in this picture, I see that the length is 12, and then the width is x. And since that's a coefficient on that variable, or that's a constant, that's a variable, we don't need any sort of multiplication symbol in between. So that is our final answer. Again, we don't need to solve for x, it just says to write an equation. If we did need to solve, it would say write and solve. Go ahead to the next problem. It says solve the equation, check your solution. So there's two parts here. You need to make sure that you show your one step of work as well as the check step. So here's our problem, 4 plus k equals 14. I'm going to draw my railroad tracks. And then on the left side of those equal sign, I want to get k all by itself. So since we have a positive 4 here, we're going to subtract 4 to get rid of it. And whatever we do to that left side, we have to do to the right side. So we're going to subtract 4 to the right side. So 4 minus 4 gives us 0. We can cross those out. We're left with just k. Bring down our equal sign. 14 minus 4 gives us 10. So that is our final answer. But to make sure that's right, we need to plug it back in for our check step. So our check step includes rewriting the equation, but instead of that k, we're going to plug in the value we found for k. So 4 plus, we said k is 10, is equal to 14. So 4 plus 10 is 14. So since 14 equals 14, we know we are correct. So let's go ahead and try the second one. 3.5 is equal to m minus 2.2. So again, I'm going to draw my railroad tracks here. On the right side of the equation here, I want to get my m all alone. I'm subtracting 2.2. So in order to undo that, or use the inverse operation, we're going to add 2.2 to the right side. And again, whatever we do to one side, we have to do to the other. But we have to make sure that we show this step. That is what is required. We need to make sure we're either showing our subtraction or our addition or whatever operation that we are using. So 2.2 or negative 2.2 plus that positive, those are canceled out. We're left with just m. And then on our left side, 3 and 5/10 plus 2 and 2/10 is going to give us 5 and 7/10. So that is our answer. But again, to make sure we're right, we're going to plug that into a check step. And we're going to rewrite this problem. 3.5 is equal to 5.7 minus 2.2. So again, to make sure this is right, just take a quick second, really line those up and check your math. Make sure you get what you should. And here we do. So 3.5 does equal 3.5, so we know we are correct. Let's keep going. Solve the equation, check your solution. Here, this is a multiplication problem. So we're going to use division to undo that. So we're going to divide both sides by 6 and 2/10. When we take 31, and we want to make sure that goes into our division house, 31, and we're going to divide that by 6 and 2/10. Make sure to make that outside number a whole number, so we have to swoop our decimal place. But when we take that 31 and do our division with 6.2, we end up with 5 equals y, because those 6.2's cancel out. So we're left with 5 equals y. Now, to make sure that that is correct, we're going to do our check step. And we're going to plug this in. 31 equals 6.2 multiplied by 5. Again, take the extra second or two and really check your math. You don't want to make a silly mistake. So we do get 31. So we know we are correct. Our next problem is 8 equals w over 3. And this is what I was saying earlier about this is going to be the most common way you see a division problem. That fraction bar means division. So I want to make sure I get w all alone. That's my goal. So I need to multiply by what I'm actually dividing by original. So 3. And we're going to multiply both sides by 3. And those 3's get to cancel out. So we're left with w on our right side. 8 times 3 gives us 24. And then one last check step. We plug that in. So 8 equals 24 divided by 3. 8 does equal 8 because 24 divided by 3 is 8, so we know we are correct. This one's a little bit different than our last problem that we had to write for our rectangle. It says write and solve. So now we're solving as well as writing an equation that can be used to find the value. So here, again, same area formula, area equals length times width. So our area here is 576. Our length, should be next there. Our length is 36. Our width is unknown, so we're going to put an x there. Since this is a multiplication problem, we are going to divide both sides by 36. So those 36's cancel out. And on our left side, we're going to do 576 divided by 36 to get what we have x to equal. So when we set up that division problem, and we do all of our division, you should end up with x equaling 16. Okay? So that, in this case, it would be 16 centimeters. So x equals 16 centimeters. Our next section says, tell whether the ordered pair is a solution of the equation. So we're going to be given a value of x and y in a coordinate point, an ordered pair. We're going to plug that in. This is our x. This is our y. Remember, every ordered pair is always x comma y. So we're going to rewrite this problem with these numbers plugged in. 24 equals 6 multiplied by 3. So we're actually going to do that math. So we're going to bring our 24 down. 6 times 3 is 18. So since 24 does not equal 18, we're going to put that slash or equal sign. And so this is not a solution. Our next problem says y equals 3x plus 4. Again, we're going to plug in our values for x and y. I always like to label them to make sure I don't get confused. So our y is 16. And we're going to plug that in. 3 multiplied by x, which is 4, plus 4. So then we have 16 equals 3 times 4 is 12, plus 4. So again, 16 equals 16. So here, since 16 does equal 16, this is a yes, it is a solution. The next thing we're going to do is identify the independent variable and dependent variable. So we're given the equation C equals 9/100ths S. And that gives the amount of C in dollars of the commission a salesperson receives for making a sale of S dollars. So here, we have to decide the independent variable. And that's the variable that can change. And that when we change it, it affects the other variable. So the only way that this would work is the sale, the number of sales, then affects how much commission this person makes. So since the sale is what we have to, how many sales we make is what we have to plug into this equation to then calculate our C, our independent variable is S, which is dollars. And our dependent variable would then be C, which is commission. Our next problem is the same idea, identifying independent and dependent. It says the equation here gives the total cost T in dollars of a meal, with a tip of P%. So here, what we can control, what we change, is the amount of percent, that tip that we are leaving. And once we calculate our tip and we decide how much we're tipping, that then can be plugged into this equation to solve for the total amount that we are paying. So here, the independent variable, what can change, is P%. And our dependent variable would then be T total cost. So the total cost that we have to spend depends on, which is where the dependent variable comes from, the amount of a tip that we leave. And last but not least, it says a movie ticket costs $8. Write and graph an equation and two variables for the following situation. So I'm going to draw a graph really quickly. Here it says a movie ticket costs $8. What we don't know is how many tickets we bought. So I'm going to put T is the number of tickets. And C is the total cost, because we don't know how much we're spending and we don't know how many tickets we're buying. But we do know that each ticket costs $8. So if I wanted to know how many tickets, T tickets I bought, the cost would equal 8 multiplied by how many tickets we bought. So C equals 8T. So that's our equation. And the amount of tickets we buy affects our total cost. So our independent variable is the number of tickets. Our dependent is cost. I'm going to label tickets 1, 2, and 3. Cost is going to go up by 8. And if I plug in, if I buy 1 ticket, I'm spending $8. If I buy 2 tickets, I'm spending $16. If I'm buying 3 tickets, I would end up spending $24, and that would continue on and on. So we're going to go ahead and leave that there, and I'm going to title this graph Money Spent on Tickets. So once we write our equation, we need to make sure we graph it and label our graph and also tell what each variable stands for. So that concludes the review video. Make sure you rewatch any section you think you need more practice on. Make sure you're studying all of your notes, and happy studying.